Hello, Riles. For lesson 1.4 on multiplication and division of rational expressions, I want to do one example and just talk again about our philosophy here. That the idea is for us to try to factor first so that we can simplify things, make numbers and expressions simpler, smaller, easier to manage first before they get more complicated. And it made me think of, I try to teach this approach, like I said, in class to my grade 9 students for multiplying fractions by hand. There's two issues that come up. One is if a student finds their fraction button in their calculator and they don't feel the need to simplify, they say, I can type this into my calculator and it'll give me my answer. Well, why would I need to learn how to do it by hand? Um, Today's lesson is why. You can't. I haven't found calculators where you can type expressions like this in and it will simplify it for you. The computer could do it for you, but you're not going to have access to that technology during quizzes and assessments. So, the other arguments that students have told me is they said, I find it easier to do top times top over bottom times bottom and then simplify. And that student's just wrong. You're allowed to have your own opinion, but I do not accept that argument that it's going to be easier here to do 1 times 2 is 2, times 3 is 6, times 4 is 24, times 5 is 120, divided by, it would have been easier if I multiplied by bigger numbers first. Let's try that in the denominator. 6 times 5 is 30, times 4 is 120, times 3 is 360, times 2 is 720. And now I need to reduce the fraction 120 720ths, which I mean, I can do. But you notice that I just divided both the numerator and denominator by 10, which meant that both the numerator and denominator shared a factor of 10. I think it was visible that both the numerator and denominator shared a factor of 10. Now I'm going to divide the numerator and denominator by 2, which I'm going to argue was visible before I made the numbers larger. Now I'll divide them both by 3, which means there's another factor of 2 and a factor of 3 in both the numerator and denominator. So I get 1/6. And sure, that's the right answer. Sometimes students also ask me, like, can I still do things this way? And my answer is, this is not a grade 11 question. So no, we're not interested in multiplying these numbers together like this anymore. I mean, compare it to, we did this in class, or an example like this in class. This 2 is being divided by that 2. This 3 is being divided by that 3. This 4 is being divided by that 4. This 5 is being divided by that 5. It's a bit of an artificial example, but it just shows you how much easier things can be when you're willing to learn a new approach of dividing first instead of multiplying first and making our expressions more complicated. Okay, you really, we're not equipped to handle this approach of multiplying first algebraically in this course, and you wouldn't want to do a question that way. Anyways, let's try another grade 11 level example. Our directions are to simplify and state restrictions. And I'll jump into a division question for you because we get practice with multiplying when we're dividing. Let's say the expression that we're trying to simplify is x squared minus 2x all over 6x to the exponent 4 plus 12x cubed plus 6x squared divided by 2x squared minus 3x minus 2 all over 9x cubed. Little monomial there. We start with an equal sign to tell our reader that this line is equivalent to the line above. So good formatting. We common factor first. That's going to make our expressions more manageable. This binomial here has a common factor of x. Trinomial down here, greatest common factor of 6x squared. You don't need to find the greatest common factor, but it will make your questions go a little bit faster, a little bit more efficient. You're not taking away 6x squared from 6x squared. That would leave you with nothing or 0. You are removing a factor of 6x squared. If you check with distribution, you could never forget that one. And my advice is leave this as a division so that you can spot your restrictions. Numerator, little x method going on here. Let's try 4 and 1. I want minus 4 plus 1. 2x plus 1 times x minus 2 check that with distribution. 2x squared minus 4x plus 1x. Yeah, it's minus 3x minus 2. And 9. Now you can factor 9x cubed into 3 times 3 times x times x times x. But most students don't bother factoring the number 6 into 2 times 3 or the number 9 into 3 times 3. Maybe I'll try that on the side when I have this written as a multiplication. Now, as a division, I'm not allowed to divide by 0, so that expression can't equal 0. I'm not allowed to divide by 0, so that expression can't equal 0. And I'm not allowed to divide by 0, so those expressions can't equal 0. The danger in going to your multiplication by the reciprocal a little bit too fast is you may lose track of the fact that this used to be a denominator. This looks like a perfect square to me, x plus 1 times x plus 1. I will multiply by the reciprocal on this step, even though I haven't stated all of my restrictions yet. I know I can go back there and find them. I multiply by the reciprocal. There we go. Okay. And then I start looking for shared factors that can be divided out. I'm not interested in doing this times this or this times this right now. It is all just being multiplied together. Here is a factor of x minus 2 in the numerator. It is being multiplied by the reciprocal of x minus 2. So those will divide. I'm not allowed to do this across a sum or a difference, which we'll see in the next lesson. I think I missed one. Here's a factor of x. There's 2 factors of x there. So let me remove one factor of x from the numerator, and I'm going to remove one factor of x from the denominator as well. That's me saying that x divided by x squared simplifies to 1 divided by x. There's an x in the denominator. Here's another couple of factors of x. There's 3 factors of x up here, and now just 1 factor of x there. You can see how this crossing out can get a little bit messy. I'm going to remove that factor of x and be left with a factor of 1. And I'll remove one of those factors of x there. The other common mistake or thing that a student misses here is the numeric factors. We concentrate just on the algebraic factors. In fact, some students don't see monomial factors. They're only looking for brackets that cancel, and that's not what you're doing. You're looking for expressions that can simplify. 9 has a factor of 3, 6 has a factor of 3. If we divide 6 by a factor of 3, we're left with a factor of 2. We divide 9 by a factor of 3, we're left with a factor of 3. This is why I think it's key to write these ones here. Never lose track of the fact that you're dividing or simplifying, because then students just don't know what to do with a 9 and a 3. They can't cancel each other. You shouldn't be using that word at all. Now, this is a little bit messy, so I might be worried that maybe I've missed a factor. I'll be able to check that on my next line. I am just going to multiply this together now, all into one big fraction. I'm going to have 1 times 1 times 3 times x squared. So how about 3x squared? In my denominator, I'm going to have 2, and then 2 factors of x plus 1. Your textbook will almost always write that like that, 2 factors of x plus 1, and a factor of 2x plus 1. And I scan, and I see I have a factor of 3 and a factor of x in the numerator. There's no factor of 3 in the denominator. There's no factor of x in the denominator. So I'm relatively confident that I'm in lowest terms. There's absolutely no need to expand the denominator. Expanding is not synonymous with simplifying. It would be harder to expand this than it would be to leave in a factored form. You generally just want it in a factored form anyways. And my restrictions, kind of ready to spot it from here. This expression can't equal 0. 6 times x squared can't equal 0. That means that x can't equal 0. Those 2 factors became this. That means that x can't equal negative 1. I've already touched on 0 being a restriction. I shouldn't write repeats. That factor of 2x plus 1 can't equal 0. That means that x couldn't be negative 1/2. And that factor of x minus 2 can't equal 0, which means that x can't equal 2. I guess the other challenge in the question is there is a lot of restrictions, and you'll find that division questions tend to have more restrictions because there's more division in them. So just double check and make sure that you have all of your restrictions before the end.